YouTube. So please leave in the comments any feedback if you have any feedback to give to us. And I'm really happy this time to get Varun. Varun has a very good experience in DevOps. So we get him here finally after a couple of months of talking. And he will share with us some cool best practices, how to use ECS and EKS. So please, if you have any question about these topics, just hit him in the comments and he will be happy to answer you. So we will start with Varun, our first speaker. Then we will have what's new with Faz after this talk, where he will talk for 10 minutes about what's new in AWS. And we will continue with our second speaker after that. Okay, so I will pass it to you, Varun, so you can present.
Sure. Thanks for my introduction, and hi all those who are watching me online. So this is my first online session in this AWS meetup. So I'm really happy to share my knowledge over here. And I believe so. Am I visible and am I audible to everybody? Yeah. So thanks Mo for a quick introduction. So I'm just letting you know about a few things for this session. For that, I'm going to share my screen, guys. So just give me a moment. Okay, so yeah, so today we're going to learn about the ECS, but before that, let me introduce myself. I have extensively 8 years of experience in IT industry, and I was currently working with the Deloitte Southeast Asia network. Okay, and I'm based in Kuala Lumpur, Malaysia right now, and I'm here in Malaysia from last 4 years, and I have an extensive experience in multiple continent about the IT work and background. Likewise, I belongs to India, so most of the northern, south, and western India I have visited over there due to the IT projects and all. And yeah, I do have some writing, habit to write the technical blogs, as well as I have write a couple of research paper also. Few of them is published in IEEE, and yep. So that's below. You can find me out on a LinkedIn, on Medium. My blog is there, my YouTube channel, as well as my Facebook page over there. So yes, you guys can go ahead and find me out on the. Just Google me out with my name, Varun Kumar. Yep. Okay, so here is my qualification. Like I have passed my master's in computer science back in India, and I have almost 6 certification, which is a few of them are from the Red Hat and Microsoft Azure, which is not mentioned here, and yeah, most of them from the AWS. So solution architect and associate level and the professional level. Yeah, and yeah, this is my extensive experience about the CI/CD pipeline and about the DevOps or DevSecOps. So I have extensively worked with one of the largest company in Malaysia named as Astro, and we have done so much of successful project implementation in terms of the DevOps back in 2018 and 2019 itself. And we have completed the multiple project with very successful delivery with internal as well as the external client. And yeah, we do have a very good knowledge about the DevSecOps as well as the artificial intelligence in Dev AI ops, right? So yeah, this is my extensive experience about the DevOps and all. Yeah, so I think I have enough explained myself. So let's go and talk about this agenda for the today's topic. So today I'm going to cover about the DevOps culture, what exactly the DevOps culture belongs to, because it's a very mixed audience I'm facing it. And as per the input of Mo and Kaushik, they said that many people are joining, those who do not have much idea about the DevOps or the technical thing, and they don't have an idea about the AWS also, like so much of things they don't know. So it's a very basic and step-by-step tutorial I'm gonna talk to you about. But before that, let's talk about the DevOps culture and discussion about the microservices and what is your Then after that, I'm gonna explain the project, what I'm gonna do it here, and then project implementation. So in the project implementation part, I'm gonna play my YouTube video, and I'm gonna explain one by one each and everything. And that video would be played by 1.75 or 2x speed, so it would be covered at the same time. because I have allotted almost 40-45 minutes for this session. So let me complete all those things within this certain period of time. So what is DevOps? So multiple people having their own definition, multiple organizations they're having their own definition about the DevOps. And DevOps is a tool, like these must of tools we need to use in the DevOps terminology. Or if you are going to do something about the CI/CD pipeline, so it is specific over there. So for me, DevOps is not a tool set. DevOps is not a IT industry technology, or it's not a proper mindset kind of thing. For me, DevOps is a culture. So we have to, as an IT industry or an IT guy, we have to adapt this culture. So whenever I'm saying culture, that includes your IT industry, your process, your technology, the people management, the business management, operational thing. Whenever I'm saying operation, that means in on-premises too, we can utilize DevOps. And if you are talking operation in on-premises, that means we are discussing about the security team, the network team, the architecture team, and multiple other teams, available there in the IT folks, such as development and the testing also. So combination of each of combination of each, it makes a culture which we include on the top of the agile methodology, which known as a DevOps. So yeah, DevOps is a culture. Here you can see how I'm going to define this culture over here. So this particular slide, you can see the build section is in the middle, and the development and the DevOps section is in the separate part, and it includes the business. It includes the operations. It includes the business idea, revenue, value. All those things is a part of the IT industry. Is a mix of that culture. It seems to be a DevOps culture. So before explaining this slide, let me tell you something about the technology, process, and businesses. So what are the technology affected from the DevOps, and how the processes are affected and make modified and make itself a very good and faster manner, which is a very valuable and very cheaper compared to the previous one. So the process management as well as the business, how it gonna affect it, and what is the benefit of that. So so in technology wise, we can utilize the scaling capacity, which can be scaled up and scaled down based on our need, and we can save the money, we can save the time with the scaling capacity. We can optimize few things in the cloud based on our own requirement. And the topmost thing, the release ready. So when I'm saying release ready, so now the DevOps comes in terms of the dev. This side is a dev and this side is a ops. So those who are currently working in IT, or they have experience like 2015, 16, like people are working in silos mode. The development team has a separate silos, room, as well as the tester are sitting in somewhere else. They don't communicate, oftenly each other. And the operational part, whenever I'm saying operational part, I'm pretty specific about the system administration. Those who have the server administrator, either Windows server or Linux server, or the network engineer, and all those things. So these all teams are sitting, in the silos. So DevOps will bring all them to across in the same team. They can cross-functional team work together, and they can figure it out the output. They can figure it out how we're gonna automate the thing, how we're gonna build the thing, how we're gonna promote one artifact to the another one, including security, including testing, and including your infrastructure creation also. So whenever I'm showing this image, so this image, that means we can get read from the silos, which was working in back in 2015-16 about the dev team, testing team, as well as the infra level team. So let's come back again in this DevOps slide, and here is the process flowing right. So we need to make a release over there, and that release we need to automate it in any of the automation tool. That automation tool might be Ansible, Jenkins, CloudFormation, Terraform, or anything for the infrastructure deployment. Okay. And then we have a continuous testing. So for continuous testing, we can utilize Selenium and some other tools in the testing set, as well as we can continue the promotion. So that continue the promotion, that means once you have a development artifact in your artifact repository, you can promote it to the UAT without making any vulnerability testing, without making any security testing, without making any unit testing, and so more. Okay, because you already have done it in the development factor. So once you are going to promote your thing on the UAT or in the staging environment, you can promote it directly, or you can make a changes over there, and then the final artifact you can store it and you can save the time and just promote that artifact to the production environment. So this is what the continuous promotion, and we can do it like many times in a day. Okay, it is completely against to the waterfall SDLC model, software development life cycle model. Yeah, so I'm coming over there, and I'll take just 2 more minutes about to explain what is the difference between DevOps, Agile, and waterfall model. So yeah, in the continuous promotion, then after that we can deploy that artifact to the UAT staging or the production environment, and make sure that each and every step of this whole process should be monitored and should be notified in the centralized notification system. So for monitoring, either you can use Splunk or any other software. There are multiple software available. For centralized notification system, you can utilize your email, you can utilize your SNS, or you can utilize a Slack or Microsoft Teams. So yeah, this is the complete process about the DevOps tool set and how it is working over there. So let's come and discuss about the how it is different from the SDLC waterfall SDLC model, right? So waterfall typically it's divided in a 4 region. The first region should be discussed about the planning section, then the requirement gathering section, planning section, and the implementation section, as well as the testing section. So from one quarter to another quarter in the coordinate, if you're coming to, it will take almost 3 to 6 months about that, right? And in meanwhile, you have to purchase the infrastructure things, the procurement process, and everything. So it will take almost 2 to 3 quarters, like 6 months to build any of the website on or any of the product or project in the live environment. Minimum is the 6 months required, right? In the SDLC waterfall SDLC model. But with the help of DevOps model, we can just utilize cloud. Over top on the cloud, we can automate each and everything. And yes, we could able to deploy multiple product at the same time in a very faster manner with zero manual error. Okay, so whenever I'm saying zero manual error, it's speed, consistency, all those things is directly proportional to the money. If you seeing this video and you belongs to the business development, or you belongs to the business point of business team, then all those things, the resources like time, if you can save the time, because time is directly proportional to the money. If you can save the time, you can save the money for your organization. If you can save the error time, manual error time, you can save the money for your organization. And it should be consistent. So here you can, if you are utilizing the DevOps, we can use like 200 times more frequent deployment. And it is almost 22% of unplanned work. We can rework much faster, and the faster recovery from failure is 24 times. And this all things is based on the Puppet 2016 DevOps report. Yeah, it's a quite old one, but yeah, I think it's good. So let's come back to the agenda of this meeting. So here we're gonna do some sort of a real-time project where I'm gonna deploy the ECS, where I'm gonna deploy the couple of tools from the AWS section. But before this, the prerequisite and the DevOps tool for this particular project. So basic knowledge of the DevOps: what is the container, what is Docker, and what do you mean by ECRI, which is Elastic Container Repository, ECS, Elastic Container Service, AWS Fargate, which is a serverless containerization technology from AWS, and it's a really amazing feature they have provided to us, as well as what is the task, and task, that means a pod in the Kubernetes, and task in the ECS, and the ALB, that is Elastic Load Balancer, and IAM, which is Identity Access and Management Rule. So you need to know about the basics of these terminology. And moreover, the DevOps tool, if you can see over here, so code commit is a Git technology for committing your code or for your central repository, as well as it can be the alternate solution for GitHub, GitLab, or Bitbucket. So code commit will provide that Git feature, and code build is a building tool for building your artifact in any language. So you can utilize code build. And alternatively, we know Jenkins is one of the very famous build tools. So code build is an alternate of the Jenkins for the building the artifact in that terminology. And code deploy is also a sub-solution for the Jenkins, because in Jenkins we can utilize all this code build, code deploy, and pipelining thing. But here in AWS we do have a different section for this. Yeah, so these are the okay. And code deploy, then code pipeline, where you can provide all your step one by one to run. Let's suppose first of all your developer can push the code to your code commit, then it will automatically build the artifact, which is my Docker image, and it can restore to the ECR, and from the ECR it can be deployed to my AWS ECS. So this whole process, and we can configure inside the code pipeline. And CloudFormation is one of the tools through which you can automate your infrastructure. And these are the icons over here, and these are the other serverless technology, or the DevOps tool available in the AWS. So let's move. And these are the open source DevOps tools available in that. And likewise, you can see Jenkins for the build and deploy, as well as pipelining. You can see the Datadog for monitoring. You can see Trend Micro for the security, Terraform for the infrastructure deployment and infrastructure automation, and yeah, so many of other open source tools are available. We can just go ahead and Google it out and find so many things. So I am coming to this particular slide, and I'm just moving forward. There are 10 steps to complete this project, which is a complete continuous integration, continuous deployment pipeline for Amazon Web Services, ECS, which is Elastic Container Service, ECR, which can use the repository of Elastic Container, code commit, code deploy, and code pipeline. Okay. So those who do not know about the DevOps and these big words like container and code commit and pipelining, do not worry about, guys. I have a proper solution for that. I have shared my YouTube video on my YouTube channel. You can go ahead and watch it at any time. It's a very detailed 1 hour, 30 minutes video, and each and everything step by step, you can figure it out over there. Right? And even though you have a zero knowledge about the AWS, or you have a zero knowledge about the containerization or DevOps, you can just follow my video and you can able to complete this project. And also I have a blog over there, and I given the link in my YouTube video for that blog. So you can go ahead and you can see all those things step by step in my blog. Okay. So yeah. So these are the basic 10 steps. So quickly, I'm gonna explain the 10 steps, and then I will just jump it on my YouTube video, and the YouTube video will play, and I will just explain each and every important thing over there. Okay. So first of all, we need to know about Docker. What is Docker and basics of Docker? So if you don't know anything about Docker, you have to just create one AWS account and then follow my video. We need to just create an EC2 machine, and we can install Docker over there. We can pull some images. We can write some code for index.html for web service, and then we can create a couple of one Docker file and build a Docker image. The second part is the ECR creation, which is Elastic Container Repository, where we're gonna create the ECR, and that's the field looks like that, how ECR looks like that in AWS. In this slide, you can see that. And we need to log in over there. Then we need to set up our local machine through which we can pull the image from the ECR to our local machine. Okay. And this is something about the elastic load balancer. We need to create some target group. We need to create the elastic load balancer, create some security group, and this is how it looks like. Okay. And step 4, we're going to create the elastic container service cluster. In that cluster, I'm utilizing Fargate as a cluster creation. So first of all, we need to create the task, then the Fargate cluster. We need to enable or add that ALB in the previous step, whatever we have created, and then we can test it on our browser whether site is running or not. Okay. And yeah, once this part, infra part is done, then we're going to create about the code repository in the code commit, and how to set up the code repository in your code commit. I'm going to explain it within a few seconds, right? So code build, after you commit your code to the code commit section, it can build the code and build the image of your Docker, and it can store the image to the AWS ECR. So yeah, 7th stage is to build a code pipeline. So this is how the code pipeline looks like. So you need to push the code in the source, then it can build, and then it can deploy to your ECS cluster, and your website will be up and running with the new version. So these are the steps I'm gonna tell you in the video. Okay, and here is the couple of things I need to tell you about the error and its resolution. So these are the typical error what we have found whenever we are creating the AWS CI/CD pipeline, including the Docker or the code build and the code pipeline. So these are the basic error. We're gonna find it out, and how we're gonna utilize the image definition.json and so on. I'm gonna explain in that video. And 9th one is one of the important catch over there in this CI/CD pipeline with AWS code pipeline, that the source artifact and all, just change the input. That's all. That's the 3 word in this one. Change the input, and I'm going to show you. And once everything is done, then you can see the deployment on the same ELB. The first one is before the deployment in a green color, and after that you can see the change in the blue color. Okay, so this is overall project what I'm gonna do it right now, and yeah, still I have 25 minutes in my hand, so just give me a moment. I'll stop sharing and will share my Google Chrome to play my YouTube video. Mo, can you see my screen right now?
Yeah, can.
Okay, perfectly fine. So just give me a moment. Let me bring. Okay, so guys, you can see this video here with my YouTube channel named as the Manik Cloud, as well as I have provided the same thing in my Medium blog. So this is my Medium blog for this particular course or for this particular event. Okay, in this blog, everything has been explained very clearly. So whenever you have time, you can go over there and figure it out, and let me know if you need any modification over here. Right. So just before making any other time waste, let's go jump it out and check it out how we're gonna do that. So I'm gonna mute it, and yeah, for saving time, I'm gonna play this one on the 2x. Okay, and I will explain to you and more as I have make my YouTube full screen. So let me know if there is any question. You can just interrupt me at any time. I can pause my video and I can answer the questions, right? Okay. Yeah, so here, these are the steps I'm showing you. Yeah, we just logged into the AWS. We logged into the EC2, and I'm trying to launch a new EC2 instance. And this is the procedure to launch a new EC2 instance with T2 small, which is not free. And with the basic settings, no changes, basic settings of storage. Then I'm gonna create a security group for my Docker DMZ, because in this machine I'm gonna install Docker, and I'm opening the port 80 for Apache. Here I'm gonna launch it, and I'm creating a new key pair. That's the basic things for the AWS EC2 instance. If you don't know, you can follow it, and if you know, it's well and good. As I told, it's from the scratch. So I just tagged it with the name Docker, and here I'm gonna utilize my Elastic IP. So moving forward, if I'm gonna stop my instance, my IP address should be same. So I'm just associating my newly created IP address with my running Docker machine. It is associated there. And done. We have a newly created machine with the newly elastic IP, which is static. Now I just turn on my terminal, and here is my key pair file. I'm gonna change the mode to 400 for the permission. If you are familiar with Linux, you know what is chmod and all. It's a file permission command. So now we need to SSH to our machine, SSH-I, where then my SSH-I, and then my EC2 user. Basically, the AMI Linux have the username EC2 user, and just I copied and paste my IP address and then hit enter. Now it is asking about yes and no to make it confirm. Do you want to continue with the new machine, new terminal, the remote site? And I'm pressing yes. And after pressing yes, we successfully logged into the Amazon Linux machine. Now I'm going to update this one. And before this, I just typed the sudo -i command, through which I could, just move to the root user access. So sudo -i, that means I'm utilizing root. So now here you can see the changes in the host name EC2 user -IP address, and here you can see root @IP address. So that's how we just get inside the root user. And then I'm updating the Windows machine. And then I'm updating the Linux machine. It is updated. And now I'm going to install the Docker. Very simple command. Yum install Docker. It is installing the Docker image, Docker daemon, and Docker info. And I'm seeing that my Docker is not running. So let's start the Docker. Now it is started, and we can see the status. It's running right now. Okay. Yeah, so Docker info command is here. Yeah, we just run the Docker info, and we can see the version is 19.03. And now I'm pulling the Docker CentOS 6 version. It's pulled successfully. Now I'm trying to see the Docker images. And here we can see the Docker image ID, and the repository name is there, right? So now I'm going to run the Docker, this image I'm going to run with the port number 80. And here you can see the Docker run command and -it and -p. So Docker run, that means we're going to run the Docker image. I, that means interactive. T, that means terminal. -p, that means port, whether you can define your host port as well as your container port. So you just type it and hit enter. And here you can see the changes of your host name. That means you already logged into your newly created Docker machine, where I'm installing the Apache. So my Apache is installed. I'm moving towards the HTML directory, and I'm typing the index.html file. I'm creating an index.html file. And then I will go to my browser. I'll copy my IP address, paste it here. And now I can see whatever I have typed inside my container, I can able to see that. But there is an issue. So what was that issue? I forgot to start my Apache service. So let's start the Apache. It was started. And yeah, now it's coming over there. So these are the small mistakes everybody can, it happens while running these things. So they stop starting and few other things. So these are the common, right? So port for the 80 for your host as well as for your container. So here, I just press Control D, and I can be out from my existing container. And then I put the Docker ps-a command. You can see it here, like Docker ps-a command. And this command will provide you the detail of all the Docker images, all the container which is available over here. Either it is in a running state or in an existing state or in a paused state. So everything will be visible over here. So we can saw that, yeah, it was there. And so this was the very manual way to do that. Now I'm going to show you how to do all those things in an automated way with the help of Docker. So I'm just creating a directory in the OPT directory, and I'm just entering over there. So this is the Docker file. I'm just going to copy it in my machine, and the line 1 is taking it. What is my base image? Who is maintainer? Either you can provide your organization name, your email ID, your name, and then I'm going to run the Apache and copy the index file to the HTML location. And at the last, in the red color, you can see the CMD. That means I'm going to put this command. The Apache should be run while my container is on. So this CMD command utilizing for that. And I'm exposing the port number 80. Okay. Yeah, so Docker file is done. And as we said that index.html, we try to copy it. So I'm just copying a few lines of the code for HTML. Yeah, paste it over there. And then I'm going to run the Docker build command. So the Docker build command, it will provide this. Okay, so here's the Docker build command. So this dot means the current directory. So my Docker file is running in my current directory, and the Docker build will build my image. T, that means tag, and the web server, I'm tagging my newly created image as a web server, and my dot means the Docker file is in the current directory. Now it is building my image, and it's copied my index.html, and it is started everything, and port number 80 is exposed, and it was tagged as a web server. So if I put the Docker images, I can see my image, the web server image with tag latest is available. Now I'm going to run this. So this is the command to run this image, docker run -it, and this time we are utilizing D, that means detached mode. I for interactive, T for terminal, D for detached mode, and you just need to define your port. So my port is 8080, as we have done it manually, but this time we are doing it with the help of Docker file. So yeah, it is running fine with the name Sweet Bassy. Now go ahead and check your okay. Yeah, so now I'm coming to the ECR, and then how to connect with the ECR, how to create the ECR, I'm just showing over there. So just copy this command and go to your Linux machine, and then re-tag your ECR. Just go to your Linux machine. And before that, yeah, we do require a role. So I'm just creating a role for EC2 access for my machine, and I will provide an admin access for this. And I'm attaching my role to my Linux machine. It's there. Now we can succeed the login. We just need to run the another command, which can, yeah, this is the command which can tag my web server to this particular ECR repo name. It's tagged already. Now I'm going to push my image to the Docker ECR. So as per the slide, my 2 steps has been completed. And as we do have a very less time right now, almost 10-15 minutes, so I'm little bit making more fast because we have just completed 1/4 of this video. So ECS part, Now I'm going to create a task definition right now, and the task definition name should be CI/CD task. And yes, it is 0.5 GB, the minimum memory I'm utilizing it, minimum CPU I'm utilizing it. And now I'm going to add the container. Inside the container, I have to give the name. So in this section, I'm giving the name web1, and yep, provide your image ECR details over there. Once it is done, you have to put your soft limit or hard limit. I am not utilizing anyone. I'm just giving it as simple as default. Here, the port mapping to the port number 80. That's all. And I'm creating the task. Now I'm creating the cluster. It's a very simple step. Just select the cluster, give your name, and create your cluster over there. Just click on create. Done. Now your task and cluster is ready. Just create a service through which your task should run, right? So I'm just choosing the Fargate, and automatically in the drop-down menu, I can see my task definition, and I can see the version and everything. So yeah, let's select by default whatever it is there. Give the service name. In my case, I'm giving service name 1. I'm going to run 2 container for this, so that's why I have chosen 2. And I need a simple rolling deployment. So let's go there, select your VPC and how many subnets you want on that VPC. You just select it, and yeah, that's all. And then you need to choose your application load balancer, where you have given the load balancer, but we have not created the load balancer. So this is the step to create the load balancer. It's a very simple step. Just go to the ALB, create your ALB, select your availability zone, select your security group, okay, and then create a target group. Okay, everything is default, create new, done. And let's go back to your ECS and refresh it. You can see your load balancer running over there, right? And it is available for port number 80. And I'm going to create one more target group. Okay, so this is the way we're going to create a target group from the ECS. This is a path pattern. Done. Go ahead. Next. We don't want any auto scaling. Now, here, if you want to check, this is my service security group, and I'm creating a service. So once my service is created, I'm going to the ECS and edit my security group because it has created one. In my load balancer, I have add that security group, and now I can see it's provisioning. So all the things is provisioning right now. Okay, so there is 2 tasks which is running. So if I just go over there in the load balancer, wait. Yeah, so I'm just copying my DNS from my load balancer and pasting in my browser, and it is running over here. Version 1 in green color. It's running. Okay, so we have done this things manually. Now the most important part is coming for the DevOps. How DevOps come in the picture? Because time is very low, so I couldn't create the infrastructure from the cloud formation, so that most of the people who is joining this session could be able to understand the DevOps in a manual manner also. And another session I have on Saturday with another user group, and there I'm going to talk about the infrastructure automation. Okay, so we are on the code repository for the code commit, and I'm just giving a name over there. I'm creating my code repository. And there is a catch. If you are very new to the code repository and all, then you have to be, change some setting on your IAM role. For that, you need to go to your IAM role. And now it is in your Linux machine, if you're trying to clone, it will ask the username and password. So for that, you have to go to your IAM credential. Okay, go to your IAM, go to the security credential, and here you need to just, generate a credential. So click on the generate, copy your username and password, and this is how you're gonna clone it again and give your password over here. Username is accessible, password is accessible. Now I can see my clone directory is docker-repo is available right now. Okay, so another way is to do that, to generate the SSH key. So for generating the SSH key, these are the steps. We have to create one file in our local machine and just enter few things. So before that, I need to generate a private and public key with the SSH keygen in my local machine. And I'm just created this one, and the location of these two files is on root location SSH folder. And this particular public file, I'm gonna read it, copy it, just copy this public file, go to my SSH, yeah. So wait, yeah. So this point I have missed it out. I copy this one and paste it here. Once you paste it here, it will generate an ID for you. So there is an SSH key ID. You can see that ID is available over there. Then we need to go back to the Linux machine and create a config file where you need to provide this ID, the generated ID, and it's there. Then you need to provide the file name, which is id rsa.pub, okay, which is ID and RSA. I have already saved it, and then change the mode, the chconfig. Copy this one, and then clone it to your Docker repository. Now it is, yeah, so it's cloned successfully. But if you're gonna push, yeah, so here is the git command coming in the picture. I'm adding these files, and this is the git status. Guys, I'm running out of time, so that's why I'm a little bit faster over here. Yeah, so I have already committed, and I'm trying to push the code. Now, okay, see, here is the catch. This is important thing. Now you have already assigned your SSH key there in the IAM, but still it is asking for a username and password, because you have already created this particular directory, cloned this directory from your username and password, and inside the git config, it is already there. So either we need to delete this folder and clone it again. So what I'm going to do it, I'm gonna delete this credential, generated credential. I have already deleted it, and then I'm gonna clone it one more time. I just remove it forcefully, and then here I'm gonna clone. I already cloned it and I already pushed it. Right, so all the code, whatever I have pushed it over there, it's, you can see Docker file and index.html in my code commit. So code commit till part we have done it, and let's go for the build option. So I am gonna choose the build, code build, create a project. Just I'm giving a name, very simple. Then I'm source provider. I have choose the code commit. Then which image you want to choose. So in the code commit, I have a repository, Docker repo, then I have a master branch, the environment variable, which operating system you want to choose, and I'm the Amazonian mindset guy, so I will always choose Amazon, right? And which image version. And this is one of the very important thing. If you want to do the Docker build command to run in your code build section, you need to check box this one. If you didn't check box this one, the privileged one, believe me, there is no other way to build a Docker image in code build. And this will take so much of your time. So make sure this is the cache and you don't miss it. Okay, so here I'm choosing the default VPC and everything. In the artifact, I'm gonna choose the artifact as a S3, and I'm gonna leave it as it is, right now. And once my code pipeline will generate an artifact in S3, then I'm gonna select over here. So let's move forward. my code build is already done, and I'm just deploying the code build, and I'm expecting an error. Yeah, because my build spec.yml is not there. So just quickly go to our terminal, create a build spec.file, copy these lines, test it here. So let me just quickly go through that one time. So there is a 3-phase in this. The first one is the version, and after that phases like pre-build, build, and post-build. In pre-build, we are just trying to log into the ECR. In the build command, we are trying to build an image of our Docker, and then in the post-build section, the newly built image must be pushed to the Docker ECR repository, sorry, the AWS ECR repository. So this is all steps you have to go one by one, and just go through that AWS documentation. You can find it out. So as my build specs file is ready, I'm just adding it, and I can check my code repo. The new file should be here. Make sure your ECR URI must be good, must be matched. And now again, we are facing an issue because of the access. And now we need to go to the IAM role. And inside the IAM code build, it would not have the S3 access. So sorry, it would not have the ECR repository access. So just go and give the container registry full access, right? And rerun it again. So for rerunning it, yeah, it's running. It's installing all the package. And then we can see the latest image is come to the Elastic Container registry, and the image URL is this. Now our code commit part is done, code build part is done, and my build is successfully building the Docker image, and that image can be sent to my ECR. Now it's time to change the code, and I'm going to show you manually what exactly I wanted. So manually, I'm just changing this version 1 to version 2, okay, and I'm committing over there, and you can see again my build file. This is the version 2. I can see here, and we can change the commit changes. We can see the commit changes. Now go to the deployment, go to the build, and start building it. It will create a new image with my version 2 code. And once it is available there, we have to go to the ECS, go to the task definition, and update the task manually. See, guys, it is quite long, but believe me, if you don't know, or if you're a newcomer for this DevOps or the ECS or the containerization in Amazon Web Services, this is the best video with very slowly, step by step, all manual as well as DevOps processes are available over here. So I have just updated the task with the newly created URI, a newly created Docker image in our registry setup, copied the URI, and you can see the task CI/CD task 2 is done, and we're gonna just make it update the service. And once we update the service, we can see there is an existing 2 task was running, and the 2 task is provisioning with the new version. So we have done it manually. Now we need to do it with the code pipeline. So I'm almost about to finish my session. I know Kaushik and Mo are getting late, but just allow me 10 more minutes to do that.
I think maybe if we can wrap it in 5 minutes, that would be awesome. So if we have some questions as well.
Okay. Sure, Mo. Yeah. So this was the explanation about how we do it manually, and now let's go back to the your code pipeline. So I'm just showing you about the ALB target group, whether it's healthy and unhealthy. So let's move it to the code pipeline section. Yeah. So I'm going to create the code pipeline. And I'll try to wind up in 5 minutes more. Yeah. So in the pipeline, the first stage, I'm providing the source code, source provider, and then where is my build, how my build is running. And yeah, my code pipeline is done, and I'm gonna add the ECS. That is another catch over here. Just add the ECS in your deploy and service name, and yeah, that's the image definition file. We will put it later. So my pipeline is ready. First two steps of my pipeline will be running very good, and but in the deploy section it's gonna be failed, and this is the expected behavior because the S3 would not have the proper permission. A code pipeline role would not have the proper permission for the S3 access. So I'm just adding the S3 full access over there in the policy. Yes. And this is how my artifacts looks like. All my code, everything should be stored in the S3 bucket, and ECS pipeline is getting the detail file from here, right? And you have to edit the artifacts, give the name, the code build section. These are the catches which a new user or the experienced user also, sometimes they will confuse over here. So this is how very well defined over here. And my pipeline is still failing. And everything was expected behavior, and it was already explained over there. This is how you edit your pipeline. Just change to the source artifact. Okay. And yeah, so here make sure your image name should be the container name. Yellow is I'm just copying and pasting with this CI/CD task. Yeah, I'm just replacing with CI/CD task, and I'm trying to do it. And here I did a mistake. So that's a very silly mistake, but yes, it took me so long to find it out where is my mistake. I know that CI/CD task should be matched with the container, but my container name was web1, as I explained you guys over there. So yeah. So here you can see just 2 more minutes. More.
Yeah, go ahead. 2 minutes. We can do it.
Yeah. 2 more minutes. So yeah, in the image definition file, I have to change the name with the web1 because my task definition name was web1, the container. Yeah, this one. So this is the catch, and I have missed it out, and I almost wasted so many hours to do that. But anyhow, it's a good learning. Yeah. So here I'm just putting the version 2 to version 3, and just pushing my code to my code commit, and now everything should be run as per the expected behavior. Now ECS pipeline is working, code commit part is done. Now building process is going on. It will take some time, so let me forward the video. Okay, so this code build was building your image with the newly created code with version 3. My goodness. And in the pipeline, now the deployment has been starting within a moment. Yeah, the deployment part is done, and I'm just clicking on this detail section, and then I can go ahead to check out my ECS, whether it's deploying my newly created parts or not. So yeah, primary and active section is there, and in the detail section, we can see the task. There is a 4 tasks running with version 5 and version 6. The version 6 is a newly created one. And you can see in the event, it is registered one task, it is deregistered task. So everything going as expected behavior. And once I can refresh my ALB, I can see the version 3 in blue color is available. So this is how we have successfully completed this one. And in the ALB also, you can check it out, the target group. It's a draining and healthy. So the newly created task is healthy, and the old task was draining slowly. Yeah. So this was the successful experiment, and it is already there in the YouTube. You just need to go over there in the Money Cloud channel, and you can just go through that.
Right.
That's
so
all.
this is your channel, the video you are playing from, or?
Yeah, this is my channel. Yep.
Okay, so maybe I will share it with the guys on our group as well, so they can take a look.
Sure.
On it.
I'll send it back to you. Yeah.
Cool.
So,
so is there anything else, or?
I'm done with this. I'm done with this.
Love it. I love
demonstration.
And you know, I love that we face some problem to see you how you debug this issue. So that's made it more interesting actually to follow with you. You know. So just I have so Kaushik messaged me to ask you a quick question. Like, what do you see like most common errors or people face when they do this kind of deployments? When you are working with the team or when you do it yourself as well?
Okay, so in this, the most common error more is, in IT, we are discussing about if you can save your 20% silly errors, you can save your 80% production errors, right? So errors is always be very silly. Sometimes the git command, sometimes you can, mistyping or typo mistake over there, as well as you need to understand the flow, especially in CI/CD pipeline or DevOps methodology. You just need to understand the flow. If you catch the flow, like how your code is flowing from one tools to the another tool, you could be able to do that. So make sure that integration part and the typo mistake would not be there. And yes, there are some catches which is available in Amazon. If you're not experienced, then you're gonna make so much of time to Googling out over there. So yeah, go and read the documentation of AWS properly. Do not go in the high level view, because then you are gonna stuck over there. So
correct.
Yeah.
Correct. Awesome. Really enjoy the demo, man. I really like it. So I will share the link as well for your video with everyone. And I'm pretty sure if anyone has a question, can ask you directly, right, through LinkedIn or Facebook as well. And I think there's one guy asking that you have another talk on Saturday, right? Looks like you have a lot of talk.
Yeah. 11 a.m. IST. It's a Pune user group in India.
Okay.
AWS community.
Is it gonna be live as well? We can join.
Yeah, live session on YouTube, and it's gonna be on Saturday, 11 a.m. IST in morning.
Okay.
So somewhere around 8:30 morning from Singapore time zone.
Cool. So anyone want to have another chat with Varun, please do join him on Saturday. And you can share the link as well with our user group on Facebook, so we can share it with everyone. Okay, thank you so much, Varun. Thank you so much, Varun. And whoever watching at the moment, you should like go and click subscribe to our channel so you can receive notification next time when we do the streaming, right? So I'm happy now to have our cool guy who always helping us with the user group besides Fabian and Donny and Cedric. So Faz is from AWS, and he will share with us like for 5 minutes to 10 minutes what's the cool stuff happening in AWS. So I will leave it to you, Faz.
Yeah, cool. Thanks. I don't think I'll need more than 5 minutes. Hey everyone, I'm Faz. I'm a senior solutions architect at AWS Malaysia. Just had a couple of announcements just to show what's happening around you, so you can also take part and learn stuff around. So let me just see if I can move this presentation first. All right. So first up, we have AWS Hack Days happening right now for Malaysia, and the last date for submission is July 15th. So Hack Days is an online hackathon for builders across ASEAN, and each country is having their own dates for doing this. So what's happening for Malaysia is you can work with teams, and then you can build on projects and then submit them. And within Malaysia, a couple of teams would get selected, and then afterwards they will be taken on to the finals, where they would do another hackathon in August across ASEAN. So from a timeline perspective, you can just register on the platform right now. I have the link in the next slide. After the selected teams are announced and you have the demo day, the first, I believe it's the first three who would be selected. They get a certain set of prizes, and then after that, you have the online final hackathon against the other countries, and that's where you would build a prototype and pitch your solution. This is focused a lot on builders. The fact that you're actually supposed to build stuff, we're adding a lot of webinars, and we have mentors from each country from AWS actually helping out teams. Try to onboard them quickly so that they can actually build stuff on AWS. So to know more, just go to this URL. It's online on this website, and the QR code is also available. Definitely, you can just come back to this video later on YouTube and then just have a look. Next up is DevX Connect. So DevX Connect is actually an initiative which we've started in AWS and ASEAN, where we have solution architects and specialist solution architects talking and doing live coding across on Twitch. I'll be sharing the link again in the next slide. We have different topics being covered, and we have like a variety of topics coming up every week. We initially started this as a weekly thing. Once a week we would do a session, but now with more response coming in, we're actually having more localization. So if you think that you want a very localized flavor of talks in your own language across ASEAN, just reach out to us over here and put your feedback in one of the videos, and we'll definitely have one. So currently, right now, we're having a series that's going on building intelligent apps. So if you see on the right side snapshots, we have two essays who are actually building out an app over a couple of weeks on a face recognition app, which will allow you to do event check-in in a venue. And then we have somebody else who's talking about Lambda. We had a recent senior architect actually come and talk about event-driven applications and event bridge. So definitely something you can learn with and then take back to your workplace and build something awesome. So check it out over here. This is the link for DevX Connect. And there is definitely, we are reaching out to a wider audience over here. So if you think that you also could contribute by actually being a speaker and you want to do live coding, like what Varun did right now, and you want to do it on this channel, do reach out to us. So you can just ping me. I'm available in the AWS user group on Facebook. Or you can just reach out on the group, and someone else would reach out totally. Yeah. So that's all. I have just two announcements. Yeah.
Thank you so much, Faz. Hopefully, we will get you every meetup, so you can have like update us with the cool stuff happening.
Awesome. Welcome to
it. Thank you so much, Faz. Quick thing before I go to our next speaker. So we have Amin. He's sharing. They have opening in the Islam Bank for CDX team. So they are looking for cool positions: cloud engineer, DevOps, and data engineer. Amir, please put your email in the comments so people can reach you, or your Facebook or LinkedIn page. Okay, so I'm going to our next speaker, Jerng. So at the moment, I hope I said your name correctly. So correct. Okay, so Jerng will talk about EC2 Burstable type and how to calculate or when to decide to scale to a different type of EC2s or instances. So I will leave it to you, Jerng, right now.
Alrighty. Can you hear me?
There's a bit of noises happening. Yeah, now I can. But there's a noise a bit.
Let me adjust the phone and see whether it gets better.
Yeah.
With this microphone.
I think now it's good. Now it's
okay.
Very good.
All right.
Yeah.
I just plugged out. Okay, hi. My name is Jerng. I'm not a professional IT person. I just use AWS a little bit and try to build things for my other work. So I'm going to talk about burstable instances, which are very small VPSs in EC2. So first of all, if I make a mistake, please just point it out in the comments. Because I have the comments window here, I can see your comments in the YouTube channel. If you have any questions, just throw them out there and I'll try to address them as quickly as possible. Please let me know if I make a mistake. Also, there is a list of presentation notes. I'm just going to walk through the presentation notes, which are really, really simple. And there will be a link to the presentation notes in the comments. Let me just put that out there so you can follow along. Hold on. Okay, so if you're on the YouTube channel, you should be able to see in the chat box a link, and that is a link to the same document I'm going to present that you're looking at. Okay, so EC2. I presume everybody who's using AWS knows EC2 is basically their virtual private server service. I hope I'm using all the terminology correctly. What is a burstable instance, right? First of all, let's look at what EC2 is for, right? You want to rent a virtual private server, so it has to feel like a computer, has CPU and has RAM and has storage. You don't want to just rent a kernel like a containerization service like Fargate or Lambda. So you're actually trying to rent something that feels like a computer in the cloud. So EC2 gives you that. Now, the question is that how can the guy renting it to you make it efficient as a business, right? So, these guys are pretty smart. The data centers and the AWSs and the cloud providers of the world have figured out a lot of different ways to do time sharing, right? So EC2, sometimes they'll rent you a whole core on the chip. Sometimes they'll rent you many cores in a virtual private server that has many cores. But what happens if you want to rent less than one core? So then they have to give you this model of time sharing, and that's what the burstable instances are about, as I understand it. So again, when AWS buys a server, it has many physical chips on it, and each chip would have little physical cores on that, right? For right sizing, again, if you want to pay less than one core rental per hour, they have to figure out how to subdivide it. They come up with this system, right? You all use your operating systems like Windows and Linux. Each physical core can be addressed by the operating system as a multiple virtual cores. So for example, if you actually have a chip and the cores, each individual core can be split into two virtual cores. And then somehow, given the way chips are built and the way the software is run on top of that, you can run two programs at the same time. The operating system will timeshare that core. And you get better performance on average than if you had run two programs, one after the other. You kind of like time slice them, so you run them one after the other, but very quickly you change between the two programs. So parallelization for increased utilization of the core. So you have less downtime, you have spent less time waiting. For example, if you have one program that needs to read something from the hard drive, that program A can go read from the hard drive, but it's got to wait, right? So then program B can run first. And so that's how you end up having more software running on the same physical core without wasting the asset that's already paid for. Okay, so now AWS can sell us virtual core hours instead of physical core hours. It's like you have a shop. Instead of renting it out for a whole month at a time, you can rent it to 30 different people. They just have to share the space, and you have a co-working space. So these burstable instances are like co-working spaces for software on chips. Again, so we're back to the physical cores. We have to time slice them. Okay, the firmware can subdivide from one physical core to maybe 2 or 4 hyperthreads, they're called. So that's the firmware doing some kind of time sharing, very low level, down in near the metal. But if you want to split that virtual core into even smaller bits, then you need to get some high level software. Presumably it's the hypervisor at this point to do the subdivision. And then AWS can productize that and call it burstable instances. Okay, so some rough diagrams of the architecture are being provided here. So let's say we have a physical chip. I'm going to try and highlight some of these things. You can see my cursor moving. Physical chip may have, let's say in this case, 2 physical cores. And each physical core could have, for example, 2 virtual cores, right? So AWS can take one virtual core and rent it to you, and that's product X. And it could take 2 virtual cores, put them together, and rent that to you, and that's a different product. It's got twice as many cores, right? Sometimes they don't bother to use or they can't use the servers which have virtual cores. They just straight away rent you the physical core itself. Some examples of that in the EC2 inventory are, for example, if we look now, let me get this out of the way. Okay, so the T3 family of instances, they're kind of like this. You have a physical chip, you have the two physical cores on top, for example, and each physical core has a bunch of virtual cores, right? So then the T3 Nano, for example, they take two virtual cores and they rent you 6 minutes per hour. 6 minutes times one CPU. So if you had to run both vCPUs at the same time, they'd basically be able to run for an average of 3 minutes per hour. How that happens, we have to get to that later. So the T3 Nano, for example, they're renting you two vCPUs, virtual software, virtual cores. And the T2 Nano family, for example, the T2 Nano is a specific unit in the T2 family. In this case, they don't have the hypervisor split up the physical core into multiple virtual cores. For whatever reason, it doesn't seem like hyper-threading happens over there. That's what the product documentation tells us. So when you rent a T2 Nano, you're really just renting a non-hyper-threaded single physical core, and that's what you get. But if AWS was going to rent you 6 minutes of CPU time per hour, what would happen for the other 54 minutes of that hour? You can't have your computer just turn off. So what they try and do is they try and split up that 6 minutes and make it flexible. So you can use bits of that 6 minutes in sequence throughout your entire 1 hour. And we're going to talk more about that system coming up. All right. Point 2.1, basically, they give you a kind of a battery system where they do fancy accounting, and they keep track at a sub-second basis on how many like vCPU microseconds or nanoseconds you're using, and then they count. And on average, at the end of the day, you use maybe 3 vCPU minutes per hour, but you didn't have to use it all at once. You could have used a few sub-seconds, a few vCPU microseconds per second. So some terminology, what we have is that AWS will talk a lot about vCPU credits. But what that means actually is it's a vCPU minute. So 1 vCPU credit is equal to 1 vCPU minute. It's the same thing, although they don't always use the term vCPU minute. They use the term vCPU credit much more frequently in the documentation and in the metrics, which I'll show you some of later. Okay, so terminology, a vCPU minute is a vCPU credit. Hope we're all clear on that. So for example, if you have 3 vCPU minutes per hour, it means the same thing as 1 vCPU running consistently at 5% for 1 hour. 5% of 1 hour is 3 minutes. All right, and what happens is that if your burstable instance has 1 vCPU, and it runs at, say, in this case, let's say X is 2% CPU utilization, right? Where AWS keeps track of the difference between, let's say they want to rent you 5% of 1 vCPU. They want to rent you average of 5%, but you only use 2%, right? At any one time. They actually have an accounting system where they keep track of the other unused 3% of utilization, and they store that in that little ledger and balance sheet, and they let you use it later. So it's a bit like a battery, right? And the term they have for that is that they're called CPU credits, right? Now, as your burstable instances are run, the credits can accumulate and they can get spent. So your battery can be used, it can be charged, it can be discharged, it can be, but there's a limit. So the limit that AWS puts is that you can only collect credits for up to 24 hours. After 24 hours, your battery stops charging. You can't collect credits forever and ever and spend them later. So you should have some base utilization on your instances when you're using these burstable instances. Okay, let me just go through the example. If your baseline CPU utilization, so the amount that they nominally sell you per hour is 3 vCPU minutes per hour, then your maximum credit can be that if let's say your utilization is 0, you just turned off your instance, it is sitting there unused, you use 0 CPU utilization, then you could accumulate up to 72 vCPU minutes of 72 vCPU credits in one day, because that's 3 minutes times 24 hours, right? So they sell it to you, or they rent you at the rate of 3 minutes per hour. It can collect for up to 24 hours, and after that stops collecting. Even if you have been paying them for that instance for 2 days, for example, the second day would not accrue any credits. You will not be able to save those second day credits and spend them on the third day. Basically, that's just the limit that they give you. So let's say you have you start renting your burstable instance, and you turn it off, and it starts collecting credits. After 24 hours, it stops collecting credits. Those credits will expire after 1 week. So that's something else that they have in their product description. Now, if you run out of CPU credits, your instance will really throttle down. The CPU capabilities will just drop very, very, very severely. Now, you can A, accept the limits if your software is the kind of thing that's not very important and you don't really care if it doesn't run. Or you can actually buy credits on an ad hoc basis, right? So let's say you are renting a unit where they give you 5 vCPU minutes an hour, but suddenly everybody hits your server because your game is very popular or something like that. And then you need more CPU time. You can configure your instance to start using CPU time that is provided on an ad hoc basis. And those are called surplus credits. And the mode that allows your burstable instances to use surplus credits is called unlimited mode. So you can turn that on and off while the instance is running. Okay. Some of these families have unlimited mode on by default, and some of them have it off by default. You have to read the documentation to check. Okay. While your instance is running, you can turn off unlimited mode, or you can turn it on. Right. So that's up to you. And this unlimited mode lets you buy ad hoc CPU credits, and the rate they sell you at is 60 credits, or 1 vCPU hour equals 60 credits, and they sell it to you at 5 US cents. Okay, so if you rented a unit with 2 cores, and the baseline CPU utilization that was provided with the unit was 5% of 1 core, but you ended up using 1 core 100% and the other core at 5% for the whole 1 hour, then you would get charged an extra 5 cents, basically. Okay, finally, that brings us, well, I hope that was clear so far, but that brings us to our example of how you might decide when to bump up your instance if you had bought one that's a bit too small or not providing you with enough CPU time. The reason is that because when you buy the base package of a burstable instance, those CPU credits that come with the instance as its baseline are actually cheaper than the ad hoc ones. Okay, so let's look at the example that we're going to go through. Goes without saying, for all software and all hardware deployments, you really need to just measure your own application. I can't do that for you. You need to know when you're running out of system resources. You need to know when your customers or your users are not happy, and then you need to basically bump up your system as and when, or you need to fix your software so that it runs under the available resources. That being said, let's look at a very theoretical example of how to decide when to bump up your system to a bigger one. Okay, so before we go there, some bigger picture cost minimizations you can consider. All EC2 instances, whether they are burstable or non-burstable, they can be sold in many formats. The most expensive one is called on-demand. The somewhat cheaper one is called reserved. Reserved just means that you have to commit to a usage over a period of time, and then they will give it to you for cheaper. There are also these more flexible reserved units, in a sense. It's called savings plan, where you can commit up front, but you don't have to commit to specific instance sizes. You just have to commit to a specific spend amount across a period of time. So you can commit, I'll spend $100 by the end of the year, and I don't want to know which instances I'm going to use, so I will figure that out later. But by the end of the year, I'll be sure to spend $100. Then you can use the savings plan. And the savings rate on that is very similar to the spot prices, you have to check and see one by one. So it gets cheaper. All the way down at the bottom of the price range, you have spot instances, which have lower SLAs. Your instances can be configured to terminate as soon as the market price, which is constantly moving, exceeds what you're willing to pay. Or you can set your bid price on these spot, which is basically auction units. They're auctioned in real time. You can bid above market as a rule. So that means that your instance will generally not get turned off, except in a very unusual scenario. So if you do that, then your price might fluctuate. You might actually end up paying more than the on-demand price for your spot unit if the market demands a lot of spot units, and so the price keeps going up, and you've configured your rule to keep bidding above the market price. Okay, but under normal circumstances, there's usually a lot of spare spot instances, and the prices are really, really, really low, which I will show you an example of further on down. Okay, so our very theoretical consideration. These are the leaky abstractions in our model here. Okay. Of course, when you run a VPS, you have to note that the computation, the CPU time is being divided between the operating system, just the overheads, and your application, which is what you actually want to do, right? The OS's overheads will be more constant. Your application may, have surge up and surge down depending on usage demanded, right? So that being said, let's say you run Linux on a burstable instance where they give you 5 credits per hour, and you run Linux on an instance where they give you 10 credits per hour. Or in my example here, let's say you ran one burstable instance with 3 minutes per hour and one burstable instance with 6 minutes per hour, right? What you actually find is that the one with 6 minutes an hour is going to give you more than double the application performance than the one with 3 minutes per hour, because actually the baseline overhead is the same, probably, to run your Linux or Windows operating system underneath of that. Again, just to recap a point we made earlier, when you start spending extra to buy ad hoc CPU credits, they're going to charge you 5 US cents per hour. Okay, let's look at some on-demand prices for some burstable instances. The very small ones, they're called, for example, this family is the T3A. They all come with 2 vCPUs at this range, the small, the micro, and the nano. And the cost per hour for on-demand units is somewhere between half a cent and 2 cents. So it basically doubles. It goes from half a cent to 1 cent to 2 cents, right? And each time they give you twice as many CPU credits as the baseline. The nano, which costs half a cent per hour, they give you 6 CPU credits. You pay double, then you get 12 credits for the micro. You pay double again, and then you get 24 credits per hour for the small, right? So on average, the USD cost per vCPU hour for these 3 SKUs or instances is basically the same. Okay, they are all together. Sorry, I might be off by a decimal point. We'll have to check this later. Actually, I can check it right now. Just give me a second. Run. No, it looks right. This is indeed half a cent. So okay, let's go here. Right. Okay. So after you do all the math, it comes down to an average rate of 0.047 USD per vCPU hour. So let's just call it 5 cents per vCPU hour, very close to 5 cents, right? And because it's very close to the ad hoc rate, so the base, you just pay 5 cents an hour to use 1 vCPU hour, but then when you buy ad hoc credit, it's also about 5 cents. So it's not very exciting if you're comparing on-demand instances and the ad hoc usage. It doesn't really matter whether you pay upfront or whether you pay ad hoc, right? If you're paying on demand, buying on demand burstable instances. It gets more interesting when you start to gamble a little bit with your reliability and you start to pay for spot prices, because the spot prices are much, much lower. So for example, here, while the minimum cost of a T3A Nano is around half a cent per hour, you may find that when you go on the spot, the auction market, and buy in real time, bid against everybody else for all the excess capacity that's there, the cost may be as low as 0.2 cents per hour, right? So it's way cheaper. Just again, to do a percentage comparison, let's say 5 cents is the baseline ad hoc cost for vCPU credits. Now, here, that is, if you're using an on-demand instance, you're basically only paying 6% more when you use ad hoc credits if you're paying on-demand prices as your base price. But if you're paying spot prices as your base price, which are much, much lower, then when you start to pay for ad hoc CPU credits, you're actually paying a lot more, because it's now like 200 to 250% of your base, what you were paying for the base CPU utilization. So at some point, you'll figure out that buying the CPU credits upfront in the form of just paying for a larger instance instead of buying a nano, you buy a micro, or you buy a small, or you buy a medium, it might actually be more worthwhile than to buy the smaller instance and then start paying for ad hoc credits. Because if you buy the bigger instance, you get more baseline credits upfront, and the baseline credits are cheaper than the ad hoc credits. Okay, let's look at an actual example. So let's say T3 Nano, which incidentally gives you half a gig of RAM, but that's not important because we're going to pretend RAM isn't important at all, and we're just talking about CPU right now. Mean cost per hour, let's just call that 0.17 cents USD. Let's just call that 100% baseline for the rest of the comparisons below, and that's going to be in red. Okay, so all the comparisons of percentages are against this baseline of 0.17 cents. Okay, so this machine, the T3A, it has two virtual cores, two virtual CPUs, which means when you count one CPU hour as 60 minutes, this thing can consume up to 120 CPU credits per hour, right? 60 CPU credits per hour per core. So if there's two cores, it can do 120 CPU credits. However, the T3A Nano only comes with 6 CPU credits per hour as a baseline utilization, which means that after you spend that 6 minutes, those 6 credits, you potentially could be paying for another 114 CPU credits on an ad hoc basis, right? If you had turned on the unlimited mode setting for this instance, right? So you do the whole calculation, you will find that, in addition to your 0.17 cents, you'd be tagged on with another 9.5 cents. Right, so that's a big jump. That's like when you add it together, your total cost is 5,600% of your base 0.17 cents. Right, you ended up paying a whole 9.7 cents instead of 0.17 cents. Now, this is if you had paid the on-demand price. Sorry, this is if you had paid the spot price for your T3A Nano, given this example, right? So you bought a really, really small amount of baseline CPU credit, 6 baseline CPU credits, and then you pay ad hoc for 114 after that. Now imagine that we had another instance where we run the CPU at the same utilization. So here we run 2 cores for 100% for an hour, and over there we got a new instance, but this one we paid more upfront. Because we paid more upfront, we're actually going to get a cheaper deal. Okay, so let's say instead of getting a T3A Nano, you had gotten a T3A Small. Right, so that would have been about 4 times, right? 4 times as much. Instead of giving you 6 CPU credits, they give you 24 CPU credits up front, right? So again, this unit, the EC2 Burstable T3A Small, has exactly the same number of virtual cores as the Nano, right? So it has the same capabilities, and if you turn them both on unlimited, they're going to go just as fast, and they're going to do as many computations as the other guy. It's just that for one guy, you have to buy more ad hoc credits, and that will be the guy you paid for fewer baseline credits upfront with. And right now, in this case, for example, if you had gotten with the T3A Small 24 credits upfront, and you had spent 120 credits per hour, that would mean that you have to pay an additional 96 CPU credits over the course of 1 hour running 2 vCPUs at full throttle. Right, so now your extra cost against that price of 5 cents per vCPU hour is an extra 8 cents. You put it all together, you're paying a total of 8.56 US cents to do exactly the same amount of work as in the first example. Okay? Except that here you paid 9.67 cents, but here you paid 8.56. So there is a difference in what you end up paying depending on how much you're willing to commit to upfront. Right. So for example, in concrete terms, if we're looking at a base cost for the T3A Nano of 0.17 cents, and we turn on limited mode, and you run the CPUs at full throttle, both of them, for a full hour, you'd end up paying 5,600 plus % on that base price. But if you had, instead of buying a T3A Nano and going on limited mode, if instead of doing that, you had bought a T3A small and turned on unlimited mode, you'd end up paying only 5,000%, which is a certain amount less money than in the other case. Now, that may seem like a tiny amount, but I'll expand the hourly cost to an annual cost later, and you kind of see that it makes a medium-sized difference. Let's use one more example. There is, of course, the option to just use non-burstable instances, which have a constant charge, and they give you constant access to a couple of cores. So I went and looked and found that probably the smallest constant priced EC2 instance with 2 cores was the C6G large, right? And in this case, they rent you the thing for only 3.4 cents per hour. Okay, so if, again, let's just go back here. If you had done exactly the same amount of work with a T3A Nano, right, and a T3A small, and then with a C6G large, potentially, the price difference is huge, right? Here, if you had run at full throttle, you'd have paid 5,600% of the baseline price because you were very stingy and you only wanted to buy the T3A Nano upfront, you know. And if you had paid for the T3A small, you'd have paid a little bit less. You paid 5,000% of your baseline price. But if you had actually bothered to commit to an even larger unit, the C6G large, you would only have paid 2,000% on your baseline price. So some of these price differences can be quite significant. Of course, you can model this as a so-called linear optimization. I'm not going to go into that because I'm already really bad at math, and doing that live would be a hell. Let's just look at a summary table, right? Let's say you're running a T3A Nano, and you want to know how many minutes over that baseline you would have to go before it made it worth your while to upgrade to the next unit. So, you know, it turns out it's approximately like this. If you're using a T3A Nano and you use up all your hourly credits and you use like 0.7 minutes of time, you might as well have just bought a T3A Micro. It would have been cheaper, right? And likewise, if you had bought a T3A Micro and you used up all your baseline credits and you used another like 2 minutes of time, you might as well have just started with a T3A small, then you would have saved money. So this little table here just kind of indicates that there is some kind of optimization along the way that lets you know you can calculate this upfront and lets you know based on your estimated usage of CPU or based on your empirical evidence collected from your logs about how much extra you are spending per hour on ad hoc credits, you can kind of decide whether you should just be buying a bigger instance to begin with. Now, let's just talk about the severity. Let's say in the case above, for example, you had saved, let's say you'd saved 1.11 cents per hour. Over an entire year, that 1.11 cents per hour would have translated to something like $99. So it is significant in the long run. I'm using the smallest possible examples here, but all of you know that that adds up over time. Okay. Finally, let's go to some CloudWatch metrics so that you know how to monitor these things. Here, let's look at some terminology. Okay, so they have CPU credit usage. Okay, the number of CPU credits spent by the instance for CPU utilization, right? We talked about that. CPU credit balance, right? So let's say the balance is how much the battery stores as it accumulates credits when you're not using them, right? surplus credit balance. After you've run your battery to 0, it starts to count like how much ad hoc credits you are now consuming, and that's your surplus credit balance. And when you finally get billed, that's the final one. That's the CPU surplus credits charged. I think I got that right. Let me see if my running example has a graph for us. Okay, so I've got a chart here. I've been running an instance at the back. Let me see. How do I get this back to? Okay, so I just want you to look at these 3 lines. Okay, first of all, let's look at CPU credit usage. So it's just consumption of CPU time, right? In this case, the orange line, you see, right at 7:35 on the right side over here, this burstable instance was doing basically no work. It was just sitting there. Okay, and so in order to make this interesting, make it dramatic, I had to turn on a browser, open Bloomberg, and open like 3 video tabs. And basically that gave the CPU more work to do. So as you can see, the CPU usage goes up over time. But how does that reflect visually against the credits, right? So if we look at the credit balance, while the CPU was doing very little at the beginning, it was accumulating credits. It's like storing energy in its battery. And so the accounting balance had gone up. So the green line was positive, right? But then what you see is that as the orange line goes up, which is CPU usage, it basically, the instance basically was using credits faster than it was collecting them. So then what happens is the battery starts to deplete. And then you go from positive to 0. So you have no spare credits at this point, right? When you run out of credits and you're still pushing work to the CPU, if you have unlimited mode on, which is what I did, then you'll find that you start getting, like, they start tracking, okay, now you're borrowing against future credits, right? And that's the blue line over here. So at this point, where we run out of green line, the green line goes to 0 because our bank account has gone to 0, our battery has gone to 0. Now we start borrowing, and then we start borrowing credits, meaning that we have to pay for them later, and that just shoots up. So these metrics are all there. You can use them to basically start looking at your burstable instances. For those of you who use very small workloads, otherwise you wouldn't be bothering with burstable instances at all. But just for comparison, my personal usage for burstable instances is very, very, very ghetto. I literally run a remote desktop on a T3A micro. I run a remote desktop Linux on a T3A micro, and I remote desktop into it sometimes. And that's even faster than the thin client I have in my office, which is like basically an Atom processor. So things like this will help you to calculate your cost. And I think that's it. That's it. I really don't have anything else. Happy to discuss anything you guys would like to.
Love it,
I think
man.
this is so basic that you guys all know it already.
Actually, I love it because I'd never thought, and you break it down the way you did, and I love the way how you did your slides as well, like doing through this. It was really, really awesome. So I just want to ask you a quick question. For you, as
Sure.
you said, you are not a very techie guy, right? How hard for you was it to learn all this stuff? And do you use it for fun only, or you are doing it for a project?
Okay, so I think I have to clarify something. I actually spend a lot of time looking at technology. I just don't do it. I don't get paid to do it. So I would be considered an amateur in the meaning of the word, but that doesn't mean I lack in hours of experience. So here, it took a bit of reading because I think the documentation in AWS is always very long. So it takes some time to parse through all of it and boil it down to the important bits. I think AWS can improve a little bit on summarizing its documentation, but that's a different conversation.
Okay, I hope they are listening to us now, because we have some AWS guys. Yeah. Good feedback. Yeah. Okay.
Yeah.
So that was really good to have you here, and I hope in future you will get another service and break it down for us and give it.
Sure, give me homework. I'll do this when you need a speaker.
Love it.
Okay.
Thank you so much.
Thank you for the opportunity.
Thank you so much. Okay, guys, I think that's it for today. I just want to thank very quickly Salam. Salam is working in SEEK Asia, where he helped us all in this streaming things. And today, Kaushik as well helped us. So he was behind the scenes all the time, helping with all this screen and all this StreamYard to YouTube So thanks, Koshik, and thanks, Gohar. Gohar helping us with all this design you see on Meetup and on Facebook and all this our AWS user group logo. So, and of course, thanks to Faz, Donny, and Fabian for all the support. Thank you, guys. Please don't forget to subscribe to the channel, and hopefully soon we will see you face to face after this tough time. Okay, thank you so much, guys, and I will end the stream for now. Don't forget, if you want, you can see the recording as well on YouTube. Thank you, and bye-bye.